4.5 billion years ago, the young Earth was a hellish, molten place, unfit for life. So then, how did a violent collision by an object the size of Mars, soon after the Earth's formation, create the conditions for the complex life we're part of today? The body blow to Earth knocked our planet to its current tilt, and the formation of the Moon kept it there.
The mass of the Moon out there, what it's done is it's prevented the tugs of the other planets from causing the Earth's tilt to change too much. So it's provided a real stabilizing effect on our climate because of that.
The collision also created a chain reaction of forces that set the stage for life. When the iron cores of the two planets combined, it created a larger core for the new Earth. The collision also knocked off much of the Earth's crust. This combination, with large amounts of heat pushing up from a giant core through a thin crust, likely created the conditions for sustained plate tectonics. The movement of these plates formed mountain ranges and deep basins, and the resulting volcanic activity spewed out the gases that created our atmosphere. Water eventually settled in the basins, creating oceans, leaving continents of land above. But life still had a tough time getting started in the early days of Earth.
For the first 500 million years of the Earth's and the Moon's existence, they were bombarded by debris that was still finishing up the formation of the solar system. So even if primitive life, microbes and bacteria, had formed in the first few 100 million years, they might easily have been wiped out by these giant things crashing into Earth. Now, we have evidence for life dating back to 3.8 billion years ago. That's shortly after the end of the era of heavy bombardment.
By then, due to tidal friction between the Earth and Moon, the Moon had moved slightly farther away from Earth, and Earth's rotation had slowed to roughly a 10-hour day. But since the Moon was still much closer than today, the tides in Earth's early oceans were humongous.
The tides went way inland and poured back out to sea. Twice a day, you'd get a big gulf of water in, and when it drained back out, it carried a lot of minerals and soils and other parts of the Earth's crust back out to sea with it. So there was this constant erosion and scrubbing of the land. Certainly a unique environment that might have been just right for life to develop.
The area between high and low tide, known as the intertidal region, was enormous. High tides would rush hundreds of miles inland, then back out a few hours later. During the low tides, molecular strands began forming in some of the endless miles of tide pools.
What happens when water evaporates? The H2O molecules go away and everything else is left. So the organic sludge in the pool gets more and more concentrated as the water evaporates. So this was the idea that life formed in these little pools.
Around 570 million years ago, almost 3.9 billion years after the giant impact, Earth's ocean life begins moving on to land, giving birth to complex species.
The bigger the intertidal regions, the greater the resulting diversity of life, because you can have species that live in these environments that are sometimes exposed to the sun and sometimes underwater.
Over billions of years, our Earth seems to have reached a perfect equilibrium that has allowed for the evolution of a diverse, intricate, and fragile ecosystem.
There are some climates that are too uniform, no seasonal changes and so on, and don't lead to life because there's no environmental stress. And on the other hand, climates that are too variable, where the seasons are changing all the time, and you're getting hit by an asteroid every million years. Planets like that would probably try to form life, but they couldn't get it going because things would change too fast. So maybe there's a situation that's just right in the middle, and maybe the Earth-Moon system is somewhere in that range, which has fostered not only formation of primitive life, but the evolution of that life into folks like us.
But though our moon stabilizes things, it continues to recede from us at a rate of 1.5 inches per year, while it slows our spin. Scientists estimate that we're adding 2 seconds to our day every 100,000 years.
A billion years from now, our days might last 26 hours rather than 24 hours, which is great if you're a procrastinator like me. You could always use more time.
So what will happen to the unique Earth-Moon partnership that made life on Earth possible? Will the moon eventually just drift away out of Earth's gravitational influence?
The rate will be so slow that it won't be a very big effect, and long periods of time will pass without much change. So long that we will have had time for our sun to run out of fuel and become a red giant. At that time, the Earth will be destroyed, and so will the moon at the same time.